Okay, so good morning, everyone. Today is Tuesday and we are here once again. I hope we are all fine. So let's get straight to the point. We are still on advanced JavaScript concept, and today we'll be looking at year 6. And under year 6, we look at the brief history of year 6, and we will look at some of year 6 features. We can't cover year 6 in this class. So we'll look at these features today. In our next class, look at the other features. I think we use about 3 to 4 classes to cover year 6 because it is broad, and I may like us to touch almost every angle, if not all. So under features, we'll be looking at the let and const, arrow functions, template literals, destructuring, rest and spread operators, and last but not the least, classes. So we try to understand, we try to go through the brief history of year 6, then we try to look at these year 6 features and understand what each of them bring to the table of year 6 and how useful they are. So without talking too much, let's dive in. Under the history of year 6, we'll look at the origin of year 6, reasons for introducing year 6, the key features of year 6, and the impact of year 6 in JavaScript, or let me say EcmaScript 6 in EcmaScript also. Yes. So let's begin. Year 6 was created in 1995 by Brendan Eich. It was JavaScript, but later renamed to EcmaScript. That is, yes, EcmaScript by the ECMA International Standard. That is a standard organization that oversees the language development. So year 6 is also known as EcmaScript 2015. It was introduced in 2015. And it was a significant update to the language that was finalized in June 2015. JavaScript was actually finalized in EcmaScript. Let's say EcmaScript was finalized in June 2015. So it introduced many new features that made JavaScript more powerful and easier to use. JavaScript was in existence, but EcmaScript was finalized in June 2015. So all these new features that were introduced in 2015 made JavaScript more easier to use. So the reasons for introduction, why they introduced year 6, are simply because the early versions of JavaScript has some limitations that made it difficult to write complex JavaScript applications. So JavaScript, for instance, lacked features like classes, modules, and arrow functions. So year 6 was introduced to address these problems and address the limitations and bring JavaScript up to the level of these modern programming languages like C++, Java, and so on. So I think that or those were the reasons why they introduced year 6. So the key features of year 6 are arrow functions, block scoped variables, classes, modules, template literals, destructuring, and so on. But in this class, as I said, we'll look at let and const, arrow functions, template literals, destructuring, rest and spread operators, and classes. The impact year 6 had and the impact it had and it's having on the JavaScript ecosystem overall is the major impact is on the JavaScript development. It has made JavaScript a more powerful and versatile language that can be used to create a wider range of applications also. So the introduction of year 6 has also helped to make JavaScript more popular among developers, and even beginners to the language can use JavaScript with confidence, because before the introduction of year 6, JavaScript was a kind of tricky and more difficult to write in. So now that we've gone through the brief history of year 6, let's continue to let and const. And under let and const, we're going to be exploring block scoping, temporal dead zone, reassignment and mutation, hoisting, global object properties, preventing duplicate declarations, use cases, and best practices. So what is block scoping? So before ES6, JavaScript primarily used function scoping for variables declared with var. This means the names of the variables with var, they are accessible throughout its entire function, like regardless of the curly braces defining code blocks. The curly braces are used to define code blocks, but if you use var, it means the name is accessible throughout the function, even if it is assigned before being declared. So this could lead to unintended consequences and make code harder to even read. So when let and const were introduced, they addressed this issue. With block scoping, a variable declared with let or const is only accessible within the block of code where it's declared. That's within the curly braces. So this provides more control over variable visibility and reduces the risk of naming conflict. Okay, let's say, for example, now we have okay. Let's say, for example, we have a function that's say hi. I will simply say if one, I can say if true, like so. We want to say let message equal to KodeCamp, like this, camp, like so. And then we come down here. Okay, what's happening? If true, we come down here and see log message. Want to log the message to the console. Why am I getting an error? Okay, it's a function like this. Now, if you call this function, say hi, get an error. Reference error, message is not defined. Okay, this is an error. And this is actually referred to as a temporal dead zone, but we'll get to temporal dead zones in a bit. So let's change this to var and see what's happening. Our message equals to hello KodeCamp. Run our code once more. Can you see what's happening? This message is accessible in the whole of this function. Even if it's declared only in this block, you can access it outside of this block here. But using let, or let's say const, you can't access it outside of this block. Now, if you try to run it once more, you still get an error. And now let me just like this. Like this. So get a reference or message is not defined. So that is the usefulness of let and const to avoid naming conflict and enhancing block scoped variables. Now, this prevents unintended variable modification. It enhances code readability. It also reduces naming conflict. So that's how helpful let and const can be in blocks scoping and all of that. So let's say you can actually, in this function, we have our message equal to hello. Then let's before this function, let's say message equal to code, like so. Now let's log message. Message is not defined. But this time around, the message, this variable message is defined in this say hi function, and cannot be accessed outside of the function. But if you say var message equal to, and then you come in here and say var message is equal to hello, and you call this function. The variable inside of the function takes precedence, as we discussed earlier in closures. That the variable in the inner function takes precedence. So if there's an outer function with this message, this will still take precedence. So that is how helpful block scoping is. So next on the list, we have temporal dead zone. So the TDZ, also known as temporal dead zone, also known as TDZ, refers to a specific period during JavaScript code execution where variables declared with let and const exist within a block but are inaccessible. This means you cannot access or assign a value to the variable until its declaration is encountered in the code. So the TDZ helps prevent errors caused by accessing variables before they are properly initialized. So in earlier versions of JavaScript, without block scoping, variables declared with var were accessible throughout their entire function scope, even if declared after they were used. This could lead to unexpected behavior and bugs, as we know. Let's say, for instance, we have in our say hi function, let's remove this, and we have my message is equal to hello, and we have, let's remove this and bring it down here. We have, okay, like this. So this, we're trying to access this variable before it's being assigned a value. Now let's run this function. As you can see here, it is undefined. And if you access it down here, log message undefined, and then this one you have a value because a value is being assigned to this. The reason why is because this variable is being hoisted, and we discuss hoisting later in this class. So let's change this to let, or let's say let here, and run this code once more. Now we get an error, reference error, cannot access message before initialization, because we are trying to access message before initializing it. That's why we're getting this error actually. So this is a temporal dead zone. Here, this very place is a temporal dead zone because we're getting errors. We're trying to access a variable before initializing it, before assigning a value to it. So avoiding the temporal dead zone, you actually assign variables a value before trying to access them. Or alternatively, there's a way you can go about this. If you need to use a variable before its declaration, you can wrap your code in a function and declare the variables at the beginning of that function. But that's another story. You don't need to do that. All you need to do is declare your variables, assign them values before you use them to avoid TDZs. Okay, so now that we understand what a temporal dead zone is, moving forward, we have reassignment and mutation. So reassignment simply means creating a new binding between a variable name and a new value. And it's simply like, for instance, it's like putting a new label on a box. So the old label still exists, but the variable now points to a different value in memory. So what's the whole thing we're saying here is this. Let's assume we have let x equal to 10. If you log x now you see you reassign x to 20 and you log x. Let's clear our terminal and see what we've got. So we have 10 in our first log, and the second we have 20. Because at first we're referencing 10, x was pointing to 10, but when we reassigned it, x is now pointing to 20, and that's the reason why in our second log we're having 20, because x is pointing to a different value in memory. So mutation refers to modifying the value of an existing data structure. It's like changing the content of a box without changing the label. Okay, you can change the content of the box without changing the label. That is mutation. So it applies to reference types in JavaScript, which includes objects and arrays. And we'll see that when we get to destructuring and all of that, how we can pass arrays as arguments to functions and try not to mutate them. So why mutation matters is since reference types store the memory address of data. Reference in JavaScript stored values by reference. It's the variables track values by reference and by values. So if 10 is assigned to x, this is a primitive value. So x is directly referencing 10 as its value. It's pointing to 10 as a value, but it's not pointing to it as reference. The value of 10 is assigned to x. But when you assign an object or an array to a variable, it's pointing to the address of that array in memory, not directly the values of the array. So since you are referencing the memory address of the data, reassigning a variable holding a reference type doesn't create a new copy of the data. Instead, it just changes the variable's reference to point to the same data in memory. So this simply means if you mutate the data through one variable, the changes will be reflected when you access the data through another variable referencing the same object. So let's say, for instance, we have let person equal to name, KodeCamp, and age 5. Now, if you log person, you will get the name of KodeCamp and age 5. So let's try to mutate age. Pressing age. This is equal to 4. Let's log the console and see. Pressing. As you can see now, we've mutated the age of KodeCamp. The name is KodeCamp and the age, we've mutated it to 4. So this is a reference type, and this person is pointing to this object by reference. So the object person is assigned to the variable person. So mutating the age property of the person directly modifies the original object referenced by both variables. That is simply reassignment and mutation we've discussed. And moving forward, you understand the importance of reassignment and mutation, when to mutate and when not to mutate. So hoisting, we mentioned hoisting earlier, but we'll try to understand what hoisting is. So hoisting is a specific behavior in JavaScript regarding variables and function declarations. So it can be a bit confusing at first, but when you understand it, you understand better how JavaScript work under the hood. So imagine before code is being executed, the JavaScript engine prepares your code for execution before actually running it. It will prepare it for execution. So during this preparation phase, it appears to like move all declarations of functions and variables declared with var, functions and variables declared with var. But those we declared with those that are declared with let and const are not moved. They are not hoisted. But it moves all the functions and variables declared with var and classes to the top of their current scope. It moves them to the current scope. So if the scope is a global scope, it will move all the variables declared with var and all the functions, it will move them to the top of the scope. So that is the reason why in our previous code, let me see, when we try to access, okay, dots was near, okay, yes. So when we use let is not hoisted. So that is the reason why we're getting an error here. Cannot, but if you change this to var, the variable is hoisted, but a value is not being assigned to it yet. That's the reason why it is undefined at first. When it is being assigned a value, now you can see the value. The variable is hoisted, but when you use let and const, it is not moved to the top of its current scope. Okay, so that is just hoisting in brief. Now, the idea behind hosting is functions declarations they are entirely hosted. You can call a function before its declaration in the code, and it will work as expected. Let's assume we have tests. We have this function here, and then we have the main function is here, test log test function. Now let's run our code. As you can see, the function is working as expected. Now you may be thinking you get an error. No, the function is hoisted. So before this will execute, this function will be moved to the top of the global context before being executed. Okay, so that's hoisting in play. Then variable declaration with var. For variables declared with var, only the declaration is hosted, not the initialization. So this means the variable exists before its declaration in the code, but its value is initially undefined. That is the reason why in our previous code that we wrote, we first of all got undefined and later got the value, the actual value. So there's no hoisting for let and const. Variables declared with let and const are not hoisted. They are treated as if they are declared at the start of their block. So trying to access them before their declaration results in a reference error because you are referencing what you've not declared or what you've not given a value. So there's no value to it, so you get an error. So hoisting is generally a legacy behavior from earlier versions of JavaScript. Why it's a kind of confusing, it can also be used intentionally in certain scenarios. But you should actually avoid using it only when necessary. Using var in your code is it's not advisable. You shouldn't be using var in your code. So that is basically how hoisting works. So global object properties. In the browser, the global object is known as the window. While in Node environment, it is known as global. So it acts in the browser, it acts like a central registry for properties and functions that are accessible throughout your JavaScript code. So these properties provide functionalities or information about the environment you're running the code in. So built-in functions like console log, alert, parse int, math method, and all of that. They are always available without needing to be imported or declared because they are global in the window context. So environment specific properties. So these properties provide information about the environment where your code is running. Is, for example, the navigator, which provides information about the browser and operating system. The document that represents the entire HTML document, and the window location, which provides information about the current unified resource locator, simply known as URL. And we also have custom properties. You can also add your own properties to the global object, which is generally not recommended, because if you continue adding custom properties to the global object, it will pollute the namespace and lead to conflict, naming conflict. So accessing global object properties in browsers, you can simply just call the property or the function you want to use, or you can append it with, you can append it with a window dots, because window is a global object there, so you can access it on the window object. But it's actually a cool feature, but not allowed to, because modules have replaced this. If you want to add items or methods or anything you want to add to the global object, you can easily use modules to collocate your code and not to pollute the namespace. So that's preferable than using global object properties. And in Node, I earlier showed you this. We are not in the browser. So in the browser, you can simply do something like window, and you get everything. Let's say window set timeout. And if you call this here, you get an error, because this is not the window object. As you can see, window set session storage, window session storage, window local storage, window location, and all of that. Okay, you can see log window and see what you've got to be sure. Window is not defined because we are in the Node environment, not the window environment. Okay, you can do something like log global, and you can see all of the method here. It's actually a circular dependency, the global object. We have the global itself, the clear immediate, set immediate, clear interval set, and all bunch of functions, the crypto, fetch, performance, decrypting and encrypting, all of these, set timeout, and all the functions we got. Even the fetch is supposed to be here. Okay, somewhere there, but I've not seen it. Okay, so that is simply the global object in the Node environment. So moving on here, we have preventing duplicate declarations using lets and const. So there are kind of several ways to prevent duplicate declarations in JavaScript, especially after ES6 was introduced. You can use let and const. If you don't want to declare variable, you can use you can simply say const name equal to KodeCamp, and if you try to say const name equal to, you simply get an error. If you hover over this error, you see cannot redeclare block scope variable name. Or if you have a block scope like if true, let message equal to hello, and you come down here and see let message equal to word. Now if you log message Let's log message to the console. And we have word, because this is only it's only accessible in this block. If you say message, you can see hello and word. This message here is only accessible in this block. And if you redeclare another variable with the same name, there'll be no conflict, because this is only accessible here, and the global scope has nothing to do with this. It doesn't know that the name message, the variable name message has already been declared in the block scope. So this will not cause any conflict. So utilizing strict mode, you can use strict mode to avoid duplicate declarations and namespace and modules. You can also use namespace and modules. Using use strict directive, you can say use strict. By doing this, you've activated the JavaScript strict mode. And there are some errors that JavaScript will not throw, but when you're in strict mode, it will throw every error. Okay. So now let's utilize namespaces for handling duplicate declarations. Let's say we have NS, which is name short for namespace, and an object. Now we can see ns.message equal to hello, and you see let's msg, let's message equal to hi, like so. I try to log let's say you will first of all log namespace message, and you log message here. You won't have any errors, because using namespaces or modules helps organize your code and prevent naming conflicts. So namespaces, the kind of group related variables and functions under a common name, while modules encapsulate code within a specific file so that you can import and use them. If you don't want to use them, you will not import them. And you can use linters and static code analysis to avoid renaming, to avoid duplicate declarations. And that's why prettier and ESLint, ESLint, that's why ESLint is there. It's very popular. You can set it up in your projects to avoid duplicate declarations. So moving on, we have use cases and best practices. Last but not the least on our list. So for consts, you use const to declare constant variables, and const is for variables that hold values that should not change, like throughout your program execution. So this includes strings, mathematics constants, configuration settings, and so on. So for let variables, let can be used to declare variables that need to be reassigned at some point in your code. So this applies the loops counters, temporary variables using calculations, and any data that needs to be reassigned, that need to be updated. So that's it. You can simply see, if you want to use const, you can simply say something like const pi is equal to, oh yeah, I've forgotten the, okay, 3.14, okay, this is the constant, pi constant, 3.1415 thereabouts. So you can do something like this, because pi is a constant and will not change throughout your code. Then you can reference by anywhere and then reuse it. Okay, so now we've explored let and const, and we've seen how we can use it in block scoping, avoid the TDZ, temporal dead zone, reassignment and mutation, hosting, global object properties, preventing duplicate declarations, and use cases and best practices. So moving on, we have arrow functions. Wow, it's getting interesting. So what actually are arrow functions? We've been using them, but there are things in arrow functions we really don't know. So we first of all start with the syntax, the basic syntax of arrow function. Okay, let me just, let's say we have syntax, const function. You know, it's advisable to declare arrow functions with using the const, the const and keyword. So because the function, you don't have to reassign the function. Only when you want to reassign it, but not all times that you use let. So you say const function name is equal to, so here you pass in the function parameters, para1, para2, and so on. And here, this separates the function body from the function declaration. So this here is the function body. This is the function body. So this is the basic arrow function format, the basic syntax. So the function name here is actually optional. You can leave your function like this. Let's say you can leave it like this without assigning it to any variable. So you can optionally assign it a name using const. Or arrow functions are most used as anonymous functions. So the arguments are also optional. The parameters that will be passed as arguments that are optional. The function can take 0 or more arguments separated by commas. So the arrow symbol here, this arrow symbol, this one here, separates the function parameters from the function body. While this curly brace here encloses the function body, which contains a statement to be executed when the function is called. So you can actually, in an arrow function, you can return, you say const name is equal to, you take in a name parameter. Here's your function body, and you say return name. Then you log name, you pass in text. Okay, let's change this to f name. Call your f name, and you pass in text. Now, if you log this to the console, you have test. But one sweet thing with arrow function is you don't need to actually do this. You can make it a one-liner instead of making it span across 3 lines. You can do something like this. Implicit return. You can say name. I say take in the parameter of name and return the name. So if you log this to the console, it's still the same thing. But if you want to do this with regular functions, you have to do something like function f name2 that takes in a name and returns the name. Return name. It should be f name like this. Then you say log f name. Okay, it should be 2. See, test 2. And if you log this to the console, you're still getting the same result. So this is an arrow function, and this is a regular function. So now we know the basic syntax of an arrow function. Moving forward, let's look at the no argument binding feature of the arrow function. So I believe most of us have not seen and know what arguments are. So in traditional functions, the argument object is a built-in array-like object. It's available within the function body. So all it does is provide access to all the arguments passed to the function during its call. So you can use this object, which is the argument object, to iterate through arguments, access them by index, or even use a specific number of arguments or something like that. So let's say, for instance, we have a sum function. This is a regular function, sum. So what this function does, as you can see, we did not pass any parameters. There are no parameters here. So what we want to do is we say let total equal to 0. And say for let I equal to 0. I is less than arguments. As you can see, this argument here, they are built in. It's built in the regular functions. Argument length. We say I plus plus. Now inside of this function, we want to total all the argument, total plus equal to argument. Then we'll simply return total. So what's happening here is we want to iterate over the argument passed in this function. So let's, for instance, if we pass argument of 2, 3, 5. If you pass an argument of 2, 3, 5, first of all, this will be converted to an array. Now, at first, when our total return to return with 0, then the second iteration, this will iterate and add 2 to 0, will become 2. Third iteration, first, please, and second iteration, 3 will be added to 2, making 5, and third iteration, 5 will be added to 5, making 10. So what we simply do here is we log this to the console and see what we got. Sum 2, 3, 5, like so. Then log this to the console. We have 10. Okay, this is what you're expecting, 10. Now, arrow functions doesn't have the arguments. They don't have this argument binding. So argument functions, sorry, not arguments, arrow functions lacks their own argument object binding. So this means you cannot directly access the argument using the argument within the arrow function. So there are other alternatives you can go about this. So you can go about it by actually passing parameters. You can say const sum equal to num1 and number2, where you can see you return number1 plus number2. Then see log sum 3, 4, like this, and you have 7. But actually, in a regular function, without even passing these parameters, you can use the argument to access this and then add. You can say add 0 plus add 1, or there are other ways you can go about that. Or you can use the rest parameter in this. That's where the rest parameter, and we'll talk more about the rest parameter in our coming class, in our coming subsections. So let's say here we have a scope, and inside of this function body, we have let the product equal to 1. Because if you initialize it to 0, 0 multiplied by any number will return 0. So we first of all initialize by 1. Then we see for number of numbers, all we want to do is we want to multiply all the numbers by the previous number, like this, and then we return the product. We return the product. And here we can change this to product like this. And here we can say product 3. Product 3, 4. Now you can add, okay, let's log this to the console first and see what we've got. 12. 3 times 4 is 12. Now we can add any number of arguments to this. We can add 2. Okay, this will give us 24. And then we can add 10, which will give us 240. Like so, we can add any number of arguments. The arrow function doesn't have its own argument binding, but we can go about it like that. So why does the arrow function doesn't have its own argument binding? So arrow functions are designed to be concise, and the argument object can add a kind of a complexity to functions. And the lexical disk binding. Arrow functions inherit their disk context from the surrounding scope. So it removes the need for argument to manage this binding. Its inherit is this from its surrounding scope. If it's declared in an object, the disk context is it's pointing to that object, not the function itself. But in a regular function, if it's not declared in an object, the disk function is pointing to itself. Why an arrow function? If it's declared in the global scope, the disk function is pointing to the global object. And it encourages explicit parameter usage by forcing you to define parameters and explicitly, instead of you leaving this here blank and then using the argument binding also. Okay, so those are the few reasons why the arrow function doesn't have the argument binding. And moving on, the Nodejs binding. This keyword in traditional functions, the value of this depends on how the function is called. It can refer to the global object, and that is the browser. In the browser, it is the window object, and you know it's the global disk or the global. So an object, the function is attached to as a method or the value of a specific variable that the function is called under using call or apply. So this in regular function, it's a kind of confusing. You have to take your time, go through it and understand when it is called in functions, when it's used in functions, when it's used in arrays, when it's used in the global scope and all of that. So the flexibility can sometimes lead to confusion about the intended value of this because it's kind of flexible, but you have to handle everything all by yourself. Okay, so now let's say, for instance, we have an object. We have an object here. Let's say this object is this person is equal to an object with a name of KodeCamp and a method of say greets. You know, methods in objects are functions. So we can say function. We can simply log hello like this plus. So you can actually say person greets because it's a method, you have to call it, and it's returning void because it's returning nothing. Now, if you log, let's run our code and see what we've got. If you run the code, you have hello KodeCamp because this keyword as used in this function is referring to this object. This name, that is the object name, and the object name is KodeCamp. That's the reason why we're getting KodeCamp on console. Now, let's say for another function, let's say we have another function. Second function is equal to person greets. And now we call this function, second function, we call it. Let's see what happens now. Okay, let's remove this. We don't have to call it because we're calling it here. That's the reason why I'm getting an error. Now let's call cannot read properties of undefined reading name. But our function is actually, this is actually working as intended. But now it has, it no longer has access to the context of this. Now, this function is in this object, and this is referring to this object. Now, this function is accessing this object, but then it doesn't know where the this is pointing to. So cannot read properties of undefined reading name. Now, if you want to access the this context in this function, you have to do something like this greet. You have to bind it to the person object. And now when you're function, you have hello KodeCamp. You have to bind this to the person object so as to get access to this context in this object. So in order to use it after calling another function, because this you are calling the object on the greet function directly, and you're getting access to this keyword in this context. But when you reassign it to this, which is another function, you are reassigning this function. Then you are calling that function. That function is not aware of where this keyword is pointing to. It's not aware of this context, this object context that this keyword is referring to. So arrow functions do not have their own this. They don't have their own this. So let's change this to arrow function, to an arrow function, and then see wonders. Now, if you run this code, it's undefined. Remove this, run it once more. Cannot read properties of undefined because the arrow function does not have its own this binding. So it doesn't even know what this is. It doesn't know what this is it's actually pointing to. What is this? It's even asking, what is this? Is this a this? And where is this pointing to? Oh, I don't know. So let me just try an error. And that's it. Okay. So that is how arrow functions work. They don't have their own this binding. They don't have their own argument binding. So moving on, use cases. So you decide where to use arrow functions and where to use regular functions. So arrow functions can be used as callback functions where the keyword, the this binding is not required. So you can use it in arrays. So instead of writing something like, let's see, this is equal to 1, 2, and 3. You see, see, double nums is equal to nums map, and we pass in a function, and this function simply says, okay, this function receives the number from the map function number, and it simply returns the square of the number times number like this. And if you call your function, you say dn is equal to this is we call this, what are we passing here? Nums like this. No, what am I doing? This is the function. Okay, so we log this to the console to see our results. Yes. I log this to the console to see our dn. We call our function directly. Dn is not a function. Oh, okay. Let's say it's not a function I'm trying to call it. Okay, we're just running this and assigning the return array to dn. So if you log dn, then we see our array 1, 4, and 9. Okay, so instead of doing this, you can change this to an arrow function. Then add the arrow here, and this will still work as expected, 149. And instead of returning this, you can use an implicit return like this, and then you do away with this curly braces, and we use semicolon here, and this will work as expected. Okay, so this is a one-liner. You don't have to write all the complex logic to get the work done. Then simple event handlers, you can use this in also event handlers instead of writing the function keyword in regular functions and then doing all of that. You don't have to do that. All you have to do is just use your arrow functions and then get your work done. That's it. Okay, so it doesn't have its own base binding, not this argument binding and all of that. And since we introduced arrow functions and we've proceeded to know what it lacks and how useful it is and when to use them and when to use regular functions. You can go ahead and choose anyone to use that at any moment you want to actually use it. And you can check the docs I prepared for you. You can check the GitHub repo. I've updated the docs. You can check arrow functions docs, and I believe you get more info there. So moving on, the best practices. Using it in callback functions ensures cleaner code. Callback, you can use it in callback functions to ensure cleaner code, business, object method. So if an object method has a simple body and doesn't require its own base binding, the arrow functions provide a cleaner way to define them instead of using regular functions and all of that. Okay, so now we've looked at the arrow functions and we've seen how useful and helpful they are. So moving forward, they have template literals. Most of us, we know what template literals are, but we don't know it's more powerful than it seems. So what are template literals? Okay, so in JavaScript, template literals, also known as template strings, they're a kind of a powerful string literal feature introduced in ES6, that's EcmaScript 2.15, that provide a more flexible and readable way to create strings in JavaScript. So instead of writing your strings like this, let's define that first. Instead of writing your string const string equal to name, or let's say constring equal to KodeCamp, and then logging it on the console like string like this. Okay. KodeCamp, you can actually use a template literal. And this is easy way you want to concatenate. It's still the same thing, you get your KodeCamp. But why is this so special? It can be used for string interpolation and other things. Interpolation, multi-line strings, tagged templates, raw strings, and so on and so forth. But in this class, we look at interpolation, multi-line strings, tagged templates, and raw strings. So string interpolation. Let's, for instance, you see we have, for instance, we have is equal to KodeCamp. See, routine is equal to hello. And we interpolate it, put the name here. Okay, let's see, JavaScript doesn't support, let's say NN, and become here NN. This. Now, let's say log. This is string interpolation. Then you do this, you have hello KodeCamp. So you can embed any JavaScript expression within a template using just the $ and open curly braces, the expression you wish to embed, and then close curly braces. So the expression result is then directly inserted into the string. That is beautiful. Okay, so now next item is multi-line strings. And before we continue, please, if you have any questions while we are proceeding, you can actually raise your hand or drop it in the chat, and I will easily check it out. Okay. So moving on, multi-line strings. So we can have a multi-line string that say multi-line string is equal to like this, and then we say this is KodeCamp like this. Let me bring this like so. Then if you log NLS multi-line string in the console, we have this is KodeCamp. As you can see, this is on a separate line, while KodeCamp is also on a separate line. So that is how helpful template retras are, and how we can use them for multi-line strings. You don't have to go ahead and start embedding new line characters and all of that. And we can see how they can be used as raw strings as well. And here you can move this to the next line, move this and say here, or the same. We have 3 lines. This is KodeCamp whips. Okay, so that's sweet. That's how template retras can be used to write multi-line strings. So this one, the next one here, the tagged template retras is a kind of tricky, and I believe most of us have never come across it. So template retras can also be tagged with a function. So it allows for a kind of additional processing or manipulation of the string before it's evaluated. So I'll talk and talk, but you will not understand this. So let me just demonstrate it so you can easily understand what tagged template retras are. So you can see we want to emphasize on our text. Let's see, this HTML emphasize, okay, like this. It's a function. And you see the function, not const, arrow function, regular functions, function emphasize, like text in, okay, this is the function body, and this text in the strings and the value. So in here, you say return string 0 plus, in Markdown, 2 asterisks are used to, they denote emphasis like this. They make the text bolder and emphasizes on it. They emphasize also on the text. So you do something like value plus, add it to actually emphasize on the text, plus string 1. Now this is confusing, but let's see how we can use it. Then we can say const value is equal to KodeCamp. Let's say const message now is equal to, then we can directly use our function like this, and then our template string or template literal, then we say hello, comma, and we can interpolate our string, our value here like this. Then down here we say log message. We have hello KodeCamp, and you can see this is this has asterisks, 2 asterisks at the beginning and at the end. So this text will be emphasized in Markdown. If you view it in Markdown, and then let me create let's say first MD. and copy this text as it is. Let me copy the results. Where's the result? Okay, hello. Then paste it in here. This is a markdown file, and then I have a markdown viewer, which we can actually use to visualize this. So let's click on it. As you can see, this text is bolder than the hello KodeCamp. It's bolder because it's being emphasized on. So that's the reason why it is bolder. Okay. So that's how powerful template retrans are. Can you see how we're using this function? Just call the function and then append it with template retrans, and then your value, interpolate your value, kaboom, you get your result. Okay, so I'm actually only introducing it to you because this is very, very powerful and you can use it for so many things. Okay, so raw strings, moving on the list, we've looked at the tagged templates, how we can tag a template to a function. And then the next item is raw strings. So, so template literals in JavaScript offer a powerful feature called the raw strings. So regular templates literals by default, they interpret escape sequences like the new line and the backward slash for double quotes or something like. Okay, what I'm trying to say is, let me just demonstrate instead of saying it. Let's say constraint is equal to main new line code count new line. You see is great. I actually come here and say this is for double quotes. If you don't want to use single quotes inside double quotes, then you say log string. Now, if you log this to the console, you have is great. KodeCamp is great because it's in this new line, and okay, and you can see I have ESLint installed, set up in my VS Code. So ESLint is trying to correct us instead of using it's changed this to single quotes. Okay, let's change back to double quotes and let me show you how. This, we are trying to escape the double quotes, and then, but if I save my code, it will simply, Prettier will simply format my code with ESLint and all of that. So I don't know which is doing the work. Is it Prettier? Is it the ESLint? I think it's Prettier. By the way, so this is interpreting this new line. That's the reason why this is great. Is on a new line. Now, if you add a space here, this great will shift a little bit inside. That KodeCamp is great. Okay, so it's actually great. KodeCamp is actually great. Yes, great. So let's say we have we don't want this to be interpreted. We can actually go about it like this. Constraint is equal to the string object dot raw. Raw is actually a static method on the string object. So you can actually tag it like this. Remove this and make it like this. Now, if you log string on the console, as you can see, the new line now is no longer interpreted. It's included in the string. As you can see here, let me just clear the terminal and run it again. You can see the new line, string raw. Now the new line is no longer interpreted and it's included in the string. So it's useful for preserving backslashes, and it's also used for security. It's used for all these special characters preservation. I can use it for security. Like if you are working with user provided data that may contain escape sequences, you can use raw strings to help prevent unintended interpretation and potential security vulnerabilities and all of that. So that is how raw strings work. So how they actually work. Let's say we have string like this. want to show you this example so you actually understand. We have a string like this. So let's say this is a directory on Windows. Double backslash, then we have users, and double backslash, we have KodeCamp. Let's say double backslash documents like this. And this is okay. And then you say another double backslash, then we have file. So test, we have our test file there, test.js like this. Now, if you log this to the console, string, the backward slashes are preserved because you are using the first one to preserve the second one. You're using the first backward slash to preserve the second backward slash. This is because we are not using the string raw. We're not using the raw method to do this. So we can actually do this. But if I'm using the raw method, let's just copy this and paste it here and change this to string 2. And use string raw. And this time around, we remove the second backward slash, the first one, any one, just remove one. And we log console like so. And we have this, we still have the same thing. So this is doing that for us under the hood. We don't have to include this to escape the second backward slash. We just use string raw to preserve the slashes. And let's say we remove the string raw here, and then we try to log this to the console. As you can see, we have use KodeCamp documents, test, just where's the T? Okay, T is for tab. And the reason why we're having this space here, this is being interpreted as tab. Now, if you want to escape this as well, you can just add another one. But this time around, it's a backward slash, and we have our test. Or we can just change this to capital T and remove one of these. And capital T is for another thing, it's for, okay, but it's for something, I don't know. It's not for anything. So T, single, small t is for tab. And that's the reason why we're having this space here. It's document tab, est, because it's using as tab. So without using the string, the raw method on the string object, you can do the other way around, but this, I think this is more simpler. We can go about it like this. We have everything is still remains the same. Okay, so that's sweet. And that makes template literals fun. So in this case, raw strings preserve escape sequences within template literals. So using raw strings to create a raw string from a template literal, you can actually preserve any special character in there also. So they are useful for backslash representation and security and other stuff. Okay, so moving forward, have we seen the use cases of the template literals? All we've demonstrated here are the use cases, so there's no need to say, what are the use cases? You've seen how you can actually use them. So it's up to you to decide to use them at any moment you wish to actually use them. They're actually powerful and handy to use. So decide anytime to use them and you can actually use them. So moving forward, you have destructuring. Oh, this is pretty good. And under destructuring, we are beginning with array destructuring. So what is array destructuring? Array destructuring is a powerful feature introduced in ES6 that allows you to unpack values from arrays into individual variables in a concise and readable way. And under destructuring, we have array destructuring, object destructuring, default values, nested destructuring, REST syntax, the parameter destructuring, computed parameter names, destructuring analysis, and then use cases. So how do we destructure arrays? And this is simply how we can destructure arrays. Let's say we have an array of numbers, 1, 2, and let's say even 3. Then we want to destructure, you can see const. We will destructure the values here is equal to the array we want to get these values from. This is in the numbers array. Here we can see first number and second number. Now, if you log first number to the console and second number to the console, you see, clear the terminal first, and then we'll run our code. You see 1 and 2. You can actually destructure this and get hold of only the first number here. Run this. Okay, oh, we're trying to log the second number, one is destructured. We'll clear the terminal and run it again. So we have 1. So the array numbers is actually destructured on the left side of the assignment, not on the right. So if you want to destructure it on the left, while the actual array you're destructuring from is on the right side. So the first number here is the first value from the array, and then you can see the rest values. Yes. And then you can log. So we actually get to that and then look at it in there. Then you can see what we have here. The first number is 1 and the rest values are 2 and 3. You can do like that. So you can actually create a new array from this and anyhow you want to do it. Okay, so that's simply how we can destructure array. And in this case, if you don't want to destructure the second number, you want to actually only destructure the third one. First number, we skip the second number, then we say the third number. And let's this time around log third number in the console. And then we have 1 and 3. Let's clear our terminal, run it once more. We have 1 and 3, and we've skipped 2. Notice the let me zoom in a bit. Notice these 2 commas here. It means we are skipping the second number. There's nothing, we are leaving it empty. We are leaving this space empty. So we can actually use the rest parameter to destruct. We can do something like first number and rest as I earlier did, and then you can remove this first number and log the rest, and you have value. Okay, like this. Oops, I have nothing. Log the rest. You still have 2 and 3, and that is actually sweet. Okay, so introducing to array destructuring, we've learned how to destructure values, and on destructuring values, you can actually assign default values. Let's assume we have an array, and in this array we have only 1. And in destructuring, we are, in order not to encounter, if you destructure 2 values, you have an error. Okay, so now let's destructure, let's say first, okay, it's happening, first number and second number. And then we try to log the second number, then we try to log the console. Second number like this, plug it on the console. And then the first number is actually 1, but there's no second number, so it is undefined. So we can add a default value. First number is equal to 1, and we always want the second number to be, if it is undefined, we assign the value of 2 to it. Okay, let's say first number should be 2, and the second number should be 3, so that we'll actually understand what's going on. Then if you log it, now, just because we have a value for the first number, the default value is overwritten and the value in this array is assigned to the first number, but we don't have any value for the second number, so 3 is returned as a default value. Let's assume we don't have anything in the array at all, and then we run it once more, and then we have 2, 3, because those are the default values in order to avoid errors. Okay, so that is actually how to destructure arrays. And second on the list is object destructuring. How to destructure objects. And sorry to mention, but you have to bear it with me, because looking back, we have, after destructuring, we have rest and spread operators, and we have classes. So we have to, I will have to increase my speed so we can meet up with time. Okay. So sorry about that. I never promised, though I never promised, but I said I will decrease my speed, and I've been keeping up to that. Yes, I believe I've been keeping up to that, but I have to increase it so we can meet up with time. Let me just go over this concept. So let's assume we have object destructure. We have const. Let's say KodeCamp is not the person, but when we say person, I will say name KodeCamp and age is 4. Okay, so we can actually destructure the name from KodeCamp and the age. You can see const name age is equal to person. Then we can go ahead and log age. Okay. Log it to the console. We'll have KodeCamp 4. And so what's happening here is the person is an object, and on the left-hand side, the name and age are destructured. If not destroyed, you can actually do something like this. P, because P equal to person, and to access the name, you say P name and P age. P is an object. So in order to get this, you need to write this kind of syntax, simply destructure it, and never like to waste your time. Okay, so you can actually destructure with different values. So name, you can say name, and then you say full name. Instead of saying using the name, you just want to use full name, and this will still work. KodeCamp 4. Okay, so default values. Let's assume we have an empty object here, and then we have name. We can actually assign this name to, okay, let's not use name, let's just use full name equal to KodeCamp and age equal to 4, because we don't have values in our object. And then we try to run this, we still have KodeCamp 4, but in case we have age here of 30, and we run our code, we have KodeCamp 30 because we have the value, the key age has a value 30, and the default value here of 4 will be overwritten by this, is it overridden or overwritten? Oh, overwritten by this value 30 here. Okay, so nested destructuring. Let's look at nested destructuring. So this assume we have an object of data is equal to user, and this user takes a name of KodeCamp and address. It also takes an address of city, Aqua bomb like this. Oh, it's a quite bomb city. I don't really know, but that is, I think that's where KodeCamp is situated. Codehouse, the parent company of KodeCamp, that's where it's situated. And oh, what am I really saying? That is where it's located. I I don't really know what they say. So we say country, and we say Nigeria. Say Nigeria, yeah. Country Nigeria. And we want to destructure this. How do we go about destructuring this? Then we can say empty object is equal to data. We want to actually destructure, we want to bring out the properties inside of this. So we have, first of all, let's try to destructure user. Then let's log user to the console. Okay, log user. Okay, now a user is actually another object that has the name and address inside of it. Now you can actually destructure this user and bring out a user. You want to destructure and bring out the name and the address. So now let's log address and see what we got. We have city, Akwa Ibom, and country is Nigeria. So inside of the address, we also want to destructure it and then bring out the country. So here we can come here and say log country, or it's country, not county, country, like this. So let's log it to the console. I'll have Nigeria. So this is how nested objects can be destructured. I can also use the rest property. Let's say, for instance, we destructured inside the user, we structured the name. We can also use the rest property like this, and we want to log rest. This is not array, this is object. So what do we got here? Okay, the rest, now we have the address because we already have the name. And the rest here, the name, the rest we take at the address. So the address has a city and a country. So we have address, city, and country. So that's sweet. And inside of here, we can also have our address, and we can have rests. Rest, it's still the same thing. Rest, 3 dots. It's not 2 or 3 dots. And then we can log rest, and then we have the city and the country. It's the same thing as rest here. But this time around, notice we only have the city and the country. But using, applying the rest here, see what it returns. The address key is included before the city and the country. Okay, so that's how we can destructure objects. Okay, so moving on, we have default values. We've been using default value, but let's take a look at them once more, and then nested. Okay, we've looked at nested destruction just now. Then we'll also look at the default values, how we can assign default value to objects and arrays. So the next thing to look at now is the rest syntax, which is the rest parameter. You can call it the rest parameter, also now the rest syntax, anyhow you want to call it. You can do something like const data is equal to new KodeCamp and age 4. So you can see const, you can say name age equal to data. Then you can see you have location Nigeria like this, and you want to destructure only the name, then the rest you just want to have it here. Then you can log rest on the console like this. Then logging rest on the console, you have location age 4 and location Nigeria, because the rest we have destructured the name, the remaining items are age and location. So this is the rest parameter. This is in objects, and we've used it in arrays. So no need going back to check arrays. So moving on, we have parameter destructuring. So what is parameter destructuring in JavaScript? This extends the power of destructuring to function parameters. So what it does is it allows you to unpack elements from arrays or properties from objects passed as arguments into individual variables within the function body. Okay, so this may kind of sound confusing, but then let's see how we can go about that. Let's assume we have function that takes let's say greet, that takes a name and age. So what this function basically does is it's greet up. Okay. It will log let me just use template trust. Let's see. Hello. Let's see. Let's say I am. Let's say hello. Name. Let's just say age. Age. Like this. So if you want to use this function, you can actually say call greet and pass in KodeCamp and for like this. This is how it is being done. Hello KodeCamp, you are 4. But then you can also do something like this. Data const ads equal to KodeCamp 4. Then you can spread these ads like this. Now let's see what we've got here. We still have our result. Hello KodeCamp, you are 4. So instead of directly passing in this argument, this parameter is passing in the argument, you just pass as an array and then spread it in the function as argument, and the function will simply utilize, or you can bring this in here like this. Then remove this. Let's see what it got. Hello KodeCamp. Okay. You are getting hello KodeCamp. Okay, this is because it's accessing the first element, but it's not being spread. Okay. Hello KodeCamp. KodeCamp 4, you are undefined. Okay, so it's actually hello. It's actually logging the array. So you have to spread it. And this is getting the first 2 items over there, then logging it here as a first argument, and then the second argument is returning. Okay, so you actually have to spread it like this, not passing it directly. Because if you pass it directly, you also have to spread it by passing it directly, like okay, the way it was, like this. Like this. Oops. I'm passing in like this. Array KodeCamp and 4 like this. And then remove this one. This will work as expected. So we now have hello KodeCamp, you are 4. Okay, so that is just the logic. Now destructuring object arguments, parameter destructuring. We still under parameter destructuring. We also look at destructuring object arguments. So we have a function here that says create data. We have this data it actually takes data, and what it does is, let's say it's a constructor function that says const name equal to data and const age is equal to data age, like so. Now what you want to do is you can actually say date name, and you return this function can say get return function get name that simply returns let's say age, name, and age, like this. So now you have an object const obj const data object, const data object is equal to name of KodeCamp and age of 4. So what you want to call this function, you can actually call the function here, and then you can say log this to create data. So then you can pass in data. I'm just doing this roughly. I don't think it will work. Okay, it's a function. Okay, you can say const info is equal to create data. So you can pass in the data object. And inside of this log function, you can say log info. It's a function, and it's returning a string. You can actually log it like this. KodeCamp and 4. Okay, undefined. Okay, why are we having undefined here as well? Return name and age. KodeCamp and 4. Okay, undefined. I don't know the reason why it's also returning undefined, but you've got the logic. Now we can actually pass it like this, or we can do something like we can remove this and then bring in this one directly and pass it in here, and it still works as intended. We are actually passing an object. So that is basically how, and in this data, you can destructure this in the data, and then you can say name is code and age is 620. KodeCamp is 620 years old. Okay, something like this. And in here, if you don't have, let's assume you pass in an empty object, and then you drop this to the console. Oops. Okay, this dot age equal to data age. Okay, there's no data age name. How this works, still getting an error age. Remove this. I'll be doing it like this, and then let's run it once more. Okay, code and 620 because this is an empty, and then we can say age here is 4, like this. Let's see what we got. Code and 4. Okay, so this is how you can pass default parameters. You can destructure this, do anyhow you want to do it, but just make it right. So you can, there are also computed parameter names. Let's say we have a function of greets that takes in a name and it simply logs hello. It's 0, not an O. Hello plus name, like this. And then what you do is you can simply say greets KodeCamp. Then if you run this function, it will simply log KodeCamp. But computed parameter names introduce brackets around the parameter name. So it allows you to place it allows you to place an expression inside those brackets. So this expression is evaluated at runtime, and the result determines the actual name of the parameter. Okay, so there's another thing you can do here. You can do something like say const n equal to code, and you can say n plus camp like this. And then if you run this function, you see hello KodeCamp. You can actually do this in your arguments. This concatenation, you are concatenating this string. You can actually use template strings, template literals to interpolate this camp in the code, and it will still work as intended. So in here, you can actually do something like this. You can see greet. You can see name is equal to code. Then remove this one like this. Oops, you are getting an error, and it's not defined. Oops, not here. It's here. It's here. Name is equal to code like this, and we call the function here. We run it without arguments. Oops. Undefined is not iterable. Offset the function. Function greet name code. Okay. So what's the error? Same. Okay. We have name code. This array rating. Okay. So I'm getting an error here. Oh. Okay. So I don't know why I'm getting this error, but then okay. Hello. Okay. And now here we see code name. This is name, and here is greets. And we have our name. Oops. We have greets plus name. It's G. And in here we have name. This is some. Just for testing. And some. Okay. Okay, this messing around, but then simply you can go test that out. Let's just move on. Okay, so destructuring analysis, we have already learned how to destructure. Let's say we have an array of numbers equal to 1, 2, and 3. And then these are just let's say these are just coordinates. Then say x, y, and z, x, y, z, log x, y, z, like so. Then we have 1, 2, 3. So instead of giving it long names, we can actually make it shorter names instead of giving all these long names. The shorter names are more descriptive and shorter because what if The longer ones are more descriptive. You can use them instead of using these shorter ones. Then object destructuring is still the same thing. Let's say we have in our object, we have name, code count, and page 4. And in destructuring this, using numbers instead of something else. Then you can say full age just for description. You can say full name, full age, and to work as expected. Oops, undefined. What mistake am I making? Oops. Names. Okay, name, full name, age, full age. Okay, we have KodeCamp 4, and then make it your full name, your full age. This doesn't work as arrays, and it works differently. Okay, so next on the list, we are done with destructuring and use cases. You already know when to use them, or you want to destructure, or you want to concise syntax, or you want a more friendly syntax. You can actually use object or array destructuring. And moving on, we have the rest and spread operators. Okay, so due to time factor, I want to quickly do something here. Under the rest and spread operators, I will give a simple example on arrays, and then also objects, and then we'll move on to classes because we don't have time. Let's see if you want to spread arrays, we have const 1 is equal to 1, 2, and then the second array 3, 4. Then you see const new array is equal to, you can actually spread this and merge number 1, spread and merge number 2. And then if you log new array on the console, what do you have? 1, 2, 3, and 4. So this is the spread syntax, and we'll actually merged the array. So instead of this, you can actually form an array. Instead of using this, you can actually say the new array is equal to array from this these two numbers. You can say number 1, number 2, like this, and you need to spread it. Spread it as well. And if you log this to the console, you still have the same result using array from to create array from other different arrays. And then you can merge objects as well. Let's say you have obj1 equal to name code, then copy this paste obj2 here. We have age of 4. Now you can see once final obj is equal to obj1 obj2. Then we log final object on the console like this. We have name KodeCamp age 4, so this becomes a single object. Okay, so that is sweet, and we can actually do this using object assign. So the object assign we have here, what we say is object assign So we are copying this arrays. We can actually copy objects. So what we are doing here, the first one is the new object we want to copy items to. So what do we want to copy? We want to copy these two objects to a new one. So we copy object 1 and object 2 to this new object. So now if you log this, these two objects are not mutated because we are just copying it. What we have is a new object with this value. We are copying this object and putting it inside this empty object. Okay. So this is a shallow copy. This cannot copy nested objects. So I wrote a simple algorithm, a simple function of deep merge that we can't be able to cover because of time factor. You can actually go through the docs and then try to see it out and look at the spread syntax, coupling arrays and objects, and we've seen that passing arrays are arguments. And you cannot mutate arrays, but because of time factor, we won't be able to, because I want to touch classes so that in our next class, we will move further. So you can go ahead and then try this all by yourself. There are examples there as well. So moving on, we have classes. And classes provide a way to create blueprints for objects. So they encapsulate data and behavior that define the characteristics of actions and objects. So in defining classes, we have something. We first of all start with the class keyword and the class name. And then open and close curly braces. And then we have a constructor that takes parameters. And this constructor has open, then the parameters we have this dot parameter 1 is equal to parameter 1, something like that. Then you can do so for the second parameter. This of parameter 2 is equal to parameter 2. Then you can add methods. See, get param like this, turn param1. This is the basic syntax for classes. So there are two major things I want us to look at classes. Actually, inheritance. Most of us, we've used classes, but we don't know what inheritance is. And methods, we have static methods and we have instance method. So let's assume we have a class. Let's talk about the static and instance method. Class, we have a math class, and this math class takes in, it has the constructor. This constructor takes in A and B. So we say this plus A is equal to A, like this, and this B is equal to B. And when we come down here, what we want to do is, first of all, we have add. And this add simply, what it does, it returns this A plus this A. This is an instance method. Then we have another method. This is a static method of subtract. And this subtract static method is what it does is it takes A, B, and then return A minus B. Not use, that's just it. Then if you want to use the subtract method, you can say plus sub is equal to math sub. Then you pass in 3, 2. Then you log sub on the console. And let's log sub. Okay, we have 1. 3 minus 2 is 1. But if you want to use the add method, you cannot do this because the reason why we are calling sub directly on this math object because it's a static method. If you want to do this with the add, you have to do something like 3, 2. Let me say new math, and then this is add. Say log add. Okay. Oh, log add. Add is a function, so call it. Is it so? No, 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 no. So what's happening? Add return. This add is not a function. Okay. Return this b is okay. So we're getting that. So what's happening? I'm trying to meet up with time, and I'm making too many mistakes. Class constructor. This add this return a minus b. Okay. So this be that's by the way. So that's the difference between a static and instance method. Okay, you need okay. Yes, yes, yes. I've actually forgotten that. Okay, add. You can see add dot add like so. Okay, it's add is a function that will return. Okay, okay. Thank you for that. I actually forgotten because I just want to meet up with time. And let's say we have this function that this implement add that simply returns A and B, simply returns this. And then we want to implement another function, sorry, another class that inherits from this class. So we have class math2. What this math2 does is it has a constructor, but then this math2 it extends the math class. So, and it has a constructor. So this constructor now takes in A. Then but we want to get access to the A in the superclass. So take note, this is the superclass and this is the subclass. And this superclass can also be known as the base class or the parent class. So this is the child class, also now known as the subclass. So calling the super keyword accesses the parameters we are passing the parent class constructor. So we can actually make use of this. And then we can come down here and see should I say square? Return this A times this A. Then we call our function sequence S is equal to new math2 and we pass in, let's say 3. Or we say return this, okay, this is multiply this B. Okay, let this be A. Let this be B. We're passing, okay, or let's say this, let this be C. This is C. We have B, C, but then this B, we want to get access to it from the superclass. Then we have B, C, then we have this dot B multiplied by this dot C. So we want to multiply it and then return it. Then we say this C is equal to C. And then in here we have 3, 4. Then we say log s dot multiply because it's simply returning, oops, this, it's returning a number. Okay, none. Okay, so why is it returning none? 3, 4. Okay, So I'm trying to get this, and it's also frustrating me. Okay, so that's just it. It's returning not a number, and because of the time factor, we're not going to debug anything. B, C, D or C, go to C, return this or B, apply of this or C. Okay, so that's just it. So you can actually inherit this and then make use of inherit the superclass. This subclass can inherit the superclass and actually make use of it by calling the super keyword to this B is actually coming from the superclass. I would actually make use of it here. Okay, so that's just it. Const n is equal to new 2, 3. Okay, so I don't really know why it's returning none, but we are out of time. And if you have any questions, please drop it on the channel. Yes, it's a kind of bulky, and we try our best. At least we've covered the basic things. And next, we move to other ES6 features. But for today, I think we've covered a lot, and there are things here you can go to docs and take a look at. You can also look at class syntax with prototyper inheritance, and if you have any questions, you can actually drop it on the discourse channel so we can discuss. But at the moment, we've come to the end of today's class, and thank you all for paying attention. We will all meet in our next class.